My name is Sangeetha Vigneswaran, and I'm a general manager at Aecon Utility Engineering. Today, I'm going to be speaking on a topic of transforming telecommunications design using ABD. So high-level agenda. Today, I'll be discussing who we are, Aecon, who Aecon Utility Engineering is, what is Automated Broadband Design and what is it going to do for Aecon, the challenges we're facing today in telecommunications designs, the goals we expect to achieve using ABD. I also have a schedule where I can share what our journey looks like for ABD, from starting with the business case to where we are now. And I have a quick 2 videos which show you how we're using it and what the use case scenario is. And lastly, future developments. What are our next steps once we're past the implementation and testing phases? So Aecon at a glance. We are a 150-year-old company, and we have $4.1 billion worth in annual revenue, over 10,000 employees, and $6.2 billion in backlog. Aecon is a North American construction and infrastructure development company. We provide turnkey solutions to our public and private sector clients. Here's a little bit of an org chart that shows you our, how our groups break down. So we have our construction segment and as well as our concession segment. Operating sectors go under both segments. So we have 5 operating segments, meaning civil, industrial, nuclear, urban transportation, and utilities. Aecon Utility Engineering falls under the Aecon Utilities umbrella. And to speak a bit about what my division does, we're the dry utility experts at Aecon. 20 years experience in engineering, $27 million worth of revenue for this year, over 200 employees, and we have $15 million in backlog. Our well-established industry relationships help us coordinate the interests of pipeline, transit, telecommunications, electrical, green energy. Once again, we are a team of dry utility experts. When we talk a bit about why our customers choose Aecon Utility Engineering, there are 3 pillars that set us apart: quality, constructability, and we provide cost-effective solutions. So quality meaning we have basically our safety is in the heart of every operations that we do and every design that we do. And our processes ensure that any design or operational changes never compromise our integrity. For constructability, the biggest advantage we have is that our engineering and construction teams work hand in hand together. We're integrated teams. We work out of each other's offices and yards, and our processes basically help us deliver jobs that have less field surprises and smoother execution and faster deliveries. And lastly, cost-effective solutions. So that's basically finding an economical way to help our clients get the best for their budget. So not cutting corners, safety is our utmost priority, but helping them create solutions that are cost-effective and reaching the high standards for safety. So just a few, I'm just going to run down, it's going to be quick for the next 2 slides. I'm going to run through basically what Aecon Utility Engineering does, our services, our divisions, and then we'll jump right into ABD. So for services, we provide design and drafting services, consulting for external clients, engineering management coordination, as well as engineering support and construction in turnkey programs. We also do SUE investigations. SUE investigations is basically subsurface utility investigations where we do daylighting, locates, as well as mapping out the utilities in AutoCAD. We have a field services team, which includes LiDAR and IKE survey. They also do data collection, asset management, mapping, and digitization in our customers' preferred GIS systems. As well as municipal, provincial, and specialty permit applications and coordinations. We have a team that runs that. We do Indigenous relations, registration, and coordination of easements. We talk to band members, get the permission to go onto their site to do field services as in Ike survey, as well as to do construction for them. We also do constructability reviews, as I mentioned before. It's one of our big advantages. We do pre- and post-flight constructability reviews. We also support on-field. Even if AUE didn't design the job, we're able to support. We have inspection and construction verification programs, and one of the main things that we do for all our clients is we custom build solutions for them. We listen to their problems, and we understand where their bottlenecks are, where their concerns are, and we've done this for one client where we basically built dashboards, GIS map viewers, and also Survey 123, which shows you a live depiction of where we're surveying for over 40,000 poles. Here's a breakdown of the divisions within Aecon Utility Engineering. So we have electrical, our electrical design for capital projects, customer projects, grid maintenance, PCCD data center projects, which include green space development, as well as overhead and underground rebuilds for civil and electrical services. We do voltage conversions, pole line analysis, hydro make-readies, chamber rebuilds, and inspections, transformer replacements, and so on. For our pipeline group, we engineer distribution pipeline designs, transmission pipeline designs, horizontal directional drilling for pipelines, conduits, water mains. We do many studies like routing studies, feasibility studies, constructability analysis studies, and microtunneling designs. For our green energy renewable group, we do solar panel rooftop solar panels for residential homes, as well as battery storage for residential homes. We do EV charging stations for commercial and residential. Special projects is mainly our subway extension jobs or LRT jobs, where we do class detection and matrix conflict matrices, basically looking at what the owner's engineer has produced for plans, finding out where the best way to move these existing utilities, whether it's gas, hydro, or telecommunications, out of the way so that we can build the subway station. We do support in place designs for them, and once the construction is complete for the subway or LRT, we do reinstatement designs, which means putting everything back in place. For telecom, we do underground structures designs, telecommunications cables designs, feeder automation design, pole line analysis, and route selection and feasibility studies. So just a bit about our broadband experience. Aecon brings over 70 years of telecommunication experience, giving us a deep understanding of broadband design and construction needs. Again, we are turnkey broadband solutions. We have full service delivery from design to installation. We have an in-house team that handles every single phase of the project to reduce delays. We have proven expertise in deployment. We're skilled in rural and urban builds. Our techniques include drilling, plowing, microtrenching, and aerial work. And we're backed by a large fleet of expert crews. Here are our locations across North America. We have a large presence in Canada and the US. Here, I'm going to just quickly highlight some of the jobs that we're currently working on. So we have the first bullet is the Gordie Howe International Bridge, which connects Windsor, Ontario with Detroit, Michigan. It's a 2.5 kilometer span bridge, a cable-stayed bridge, and has 6 lanes. 3 are Canadian bound, 3 are US bound. It's in construction right now. It's set to open in the fall. We have Idaho County, where we're in phase 1. We won phase 1 on 3 RFPs connecting cities of Orofino, Nez Perce, Granville, Idaho, and we begin construction on that, which is 30 miles of conduit fiber with 2 telecom shelters and generator stations on September 22nd. Next, we have Metronet fiber. This job is in Albuquerque, New Mexico, where we started this project in 2025, and it's expected to go until 2027. $60 million scope, where we're doing construction for the last mile urban. Work packages range from 20,000 feet to 40,000 feet. Includes placement of small and large vaults, residential and commercial installation of HDPE conduits along pre-designed routes. It's a directional drill job. The next job is in Ontario, Canada. It's for a client called Bell. We started this in 2016. I'm going to be talking more about Bell Canada throughout this whole presentation because we modeled our ABD standards using Bell standards. This job we're basically started in 2016, as I mentioned before. It's a full turnkey solution. Our revenue for this is $70 million annually, and we build over 1,200 miles of fiber annually. Turnkey solution, we design, build, splice all the jobs, installing CSPs, microconduit, new fiber cable from node to the house. Construction methods include installing an existing infrastructure, directional drill, aerial placement, and plowing. Next, we have Plenary, which is a middle mile JV in Pennsylvania. Started this in 2023. It's an extension of PTC's Eastern Fiber Optic Network from Harrisburg Tip Building to the Route 15 interchange. We're designing, procuring, and installing for this job. And finally, a bit about Kendall County Fiber, which is our client is Pivot and Kendall County. We started this in May 2025. Our expected completion date is December 2026. We're in phase 1A of 3 phases. It includes 2 rings, which is ring 1 and ring 3. And again, this includes, for ring 1, for example, it includes 28 miles of fiber, that is transport fiber, 165 miles of last mile fibers, and there's going to be 6,500 homes passed. Next, I'm going to talk a bit about our Aecon and SBF strategic partnership. So Aecon is the first major customer for SBF for telecom design. Our relationship is unique. It's not a traditional vendor-client relationship. It's more of a partnership. There's a shared investment. We're working together to co-create a solution that's tailored to fit Aecon's telecommunications design needs. With SBS, we bring the expertise in real-world challenges in telecommunications design. They bring their expertise in automation and a deep understanding in AutoCAD. And together we build a solution which basically delivers exactly what we want for a telecommunications design. We avoid the one-size-fits-all for all jobs, where we get to decide how we want to implement the changes and how we want the program to run. What is ABD? So most of you probably heard of AUD, which I think through this whole conference, everybody's been talking about it. Automated Utility Design Platform. It's designed by SBF for electrical and gas utility networks. ABD is an automated broadband designer, as Scott mentioned previously in his presentation. It's specifically designed for fiber and telecommunications broadband infrastructure. It's built on AutoCAD, and it integrates with our GIS and also our EAM systems to streamline design flows. Challenges that we're facing right now in telecommunications design is, number one, it's being labor intensive. We're spending about 300 to 1,000 hours on just one FDSA design. There's a lot of repetitive tasks, a lot of human errors happening. There's a lot of inconsistent workflows. So whether we adopt one standard or another, we're finding that we're always starting from scratch for some of our designs, whether it's still a Bell design. The market is getting more competitive. Our prices are being driven down, so we have to find a way to reduce the number of man-hours spent on our designs. Standards are consistently changing, whether it's with regulatory bodies or whether it's with the ISPs. Something's always changing, and then we have to implement it across the board to all our designers and drafters. So we're trying to find a way to make it consistent. There's shrinking timelines. Everybody wants something yesterday. So finding a solution to pump out these drawings quickly is what we're looking for. We have limited quality control when we look into fiber design. So whenever we do our fiber designs, we draft, At the end of the tail end of drafting is when we do our QC check. So if there's a major issue with our running line and we have to move our running line, that means we go from square one again. So that means a lot of man hours wasted and inconsistent workflows. Also, there's a lot of fragmented data and reporting, meaning we're compiling a little bit of everything in silos. So we're putting the BOM together once we finish our issued for construction plans. We are doing the OCalc or SPIDA calc in a separate entity or in a separate program, and then manually inputting the data back into our CAD systems. Even for reporting, whenever we're doing our QC checks, we're doing it basically at the tail end when the project is almost finalized. So those challenges have led us to work with SBF to find how can we improve our efficiency, how can we improve our accuracy. So our goals for this program with an initiative with SBS for ABD is increase productivity. We're going to reduce all the repetitive tasks that we've been working on that are time-consuming, for example, the fiber slacks, the drip loops, reduce the manual drafting through model-based designs, improve design accuracy. So by doing that, we're placing intelligent objects on our AutoCAD platform, and we're actually assigning relationships to those objects. So everything is intelligent, everything is connected, which in turn enhances our quality. Because if that object that we put that relationship to and we didn't connect the conduits, it's going to flag it as an error, a validation error. So as the user is, the drafter, the designer is drawing in AutoCAD, all these errors are going to be flagged, so we're solving it at the front end. We're solving it as we design. In addition to that, there's going to be standardized workflows. So we are putting templates together for whether the different stages of design, whether it's your high-level design, your MC, which is your permitting, or your issued for construction plans. You get to work between each model, and you can flip with just a click of a button from one model to the other, and it's highly efficient. Those templates are tailored to look exactly how we need an MC plan to look like or an IFC plan to look like. This also supports scalability. So right now, we're choosing the most complex standards, as Scott mentioned, which is Bell, and once we get this implemented, we can transfer all of this over to another ISP and use their standards to update the models, update their templates as per user preferences and their standards. This also in turn improves employee experience and satisfaction. You don't have a drafter sitting there doing repetitive tasks over and over again. They actually enjoy what they're doing more. They're drafting the design because they're assigning relationships. They're assigning something intelligent. Their BOMs are done at a click of a button. QC is being done as they draw and draft in AutoCAD, which in turn helps for their training. So the drafters are learning a little bit of design as they're correcting their errors as they go along and complete their designs. All of these goals actually accelerate our timeline. So now, since it's an intelligent design, as we're placing a line, it's not just a line, it's a conduit with fiber in it connected to a splice point, which means all of that is logged when we click the button to create a BOM. Everything spits out with the lengths, the type of materials, all of that is in one shot. It's not manually compiled anymore. So some of the key features, as I mentioned, it's a model-based design. We get to create telecom-specific templates. The templates are according to every ISP that we're going to be working with, every region that we're working with, because when you change from municipality or state to state or province to province, everything changes. Rules change, requirements change, and the level of details on each plan changes. This is rule-based automation, which helps with our QC checks. As we're designing from the get-go, we have a multi-mode workflow, which means we can shift from a permitting plan to a high-level plan to an issue for construction plan. And there's real-time quality control, as I mentioned before. QC checks are happening throughout the whole process, so there's no extra QC person required for something like this, where the drafter, the designer, or even the PM or the coordinator can do quick analysis of like all the errors that are popping up and solve it as we're going and make sure that connectivity is in every object that we put into that design. This is scalable and it's configurable, meaning that we can take this model-based design and use it for another ISP and just configure it based on their utility standards. So again, key considerations that we kept in mind when we chose ABD is consistency, productivity, and data quality. Our plans are more consistent, less human error, productivity goes up, and data quality goes up. Here is a timeline of our ABD implementation journey. So it shows you from day one, initial planning and vision that we did with Scott and team. Putting the business case together took about 60 days, getting it approved through our IS group, and also our BPMO group took about 30 days. So I would say the front end is about 60 days, roughly 60 to 90 days. And then week one would be when we started collaborating with SBS. When we got the approvals, we started working together. We figured out exactly what we want out of this ABD model. We started creating templates based on Bell, since it had the most complex standards. Took about 6 to 14 weeks. We did the product testing. So product testing means end-to-end testing, seeing if what we're implementing, the templates that we're implementing, as we're drawing these intelligent lines, is it working? So product testing is happening right now. I think we're in about maybe 3 more weeks. 2 more weeks, okay. 2 more weeks of product testing, and then it's beta deployment. So what we're doing at that point is we're assigning subject matter experts on the Aecon team to take over the tasks of what the SBS team has been doing for us. So once that's done, they're able to create their own rules. They're able to create their own, configure their own standards for a different ISP, and we have the support of SBS when we need them. And finally, the last piece is enhancement and scaling. So enhancing our designs, adding extra rules, adding extra clearances for different utilities, like if we're too close to a hydro line or a gas main, all of that's getting inputted if it wasn't inputted in the beginning by our subject matter experts, and scaling it. So here is a quick video of what we've put together so far with SBS.
ABD allows designers to place telecom equipment with precision using intelligent objects. Each item, whether a cabinet, pedestal, or splice enclosure, is inserted with embedded metadata and rules. This ensures accurate placement, automatic labeling, and seamless integration into the overall design. With ABD, conduit placement is streamlined. Designers can lay out conduit paths that the system validates for each route in real time, reducing rework and ensuring compliance with ISP standards. In addition, this allows for accurate duct formations for connectivity purposes. ABD supports complex duct formations, including multi-cell microducts. Designers can configure duct banks with predefined templates, ensuring consistent layering and spacing. The software checks for constructability and alignment, making duct design faster, more accurate, and scalable across projects. Cable routing in ABD is intelligent and rules-driven. Designers can place fiber or coaxial cables with automated slack loops, terminal assignments, and splice counts. The system tracks cable paths across ducts and conduits, ensuring logical connectivity and reducing manual errors. Terminals are placed using telecom-specific templates that align with ISP standards. ABD ensures each terminal is correctly connected, labeled, and validated for capacity. Real-time checks confirm splice limits and terminal distances, improving field readiness and documentation accuracy. ABD's live quality control engine runs continuously during design. It flags clearance violations, duplicate assignments, and missing connections instantly. This proactive validation reduces post-design QA/QC, accelerates timelines, and boosts confidence in every deliverable.
I have one more demo video. So
ABD allows designers to place telecom equipment with precision using intelligent objects. Each item, whether a cabinet, pedestal, or splice enclosure, is inserted with embedded metadata and rules. This ensures accurate placement, automatic labeling, and seamless integration into the overall design. With ABD, conduit placement is streamlined. Designers can lay out conduit paths that the system validates for each route in real time, reducing rework and ensuring compliance with ISP standards. In addition, this allows for accurate duct formations for connectivity purposes. ABD supports complex duct formations, including
Sorry, that was the same one. I'm going to play the next one.
ABD enables seamless transitions between design stages. With a single click, concept designs evolve into municipal consent mode, activating detailed validations like clearance zones. This reduces manual rework and ensures every stage builds on a validated foundation. Line connectivity is visualized in real time within ABD. Designers can trace fiber paths across terminals, splice points, and conduit segments. This ensures logical routing, accurate documentation, and immediate detection of breaks or misalignments in the network. ABD allows designers to switch construction types like aerial, underground, microduct, directional drill, or open trench on the fly. Each change updates associated rules, clearances, and materials automatically. This flexibility also supports diverse deployment scenarios. Beyond basic adjustments, ABD empowers designers to manipulate running lines with precision. You can introduce curves, elevation changes, or offsets to reflect real-world conditions. As you reshape the path, ABD's live validation engine checks for clearance violations, depth requirements, and connectivity integrity. ABD supports embedded construction notes and ARBs directly within the design. Field instructions, permit references, and build annotations are linked to specific assets, improving clarity for crews and streamlining as-built documentation.
Okay, that was the final demo video.
ABD.
Okay, thank you. We're not replaying that again. So just the last couple of slides. So I just want to talk a bit about the next steps and what our Aecon advantage is. So right now we do our own data collection and extraction, and we can put it in different platforms, whether we want photos or video log, or model it in our OCalc software, SpiderCalc, or PLS CAD. We can also convert it to a database or a GIS system, which is the front-end solution all packaged together. Future state, what we're thinking is all of this can be imported in, converted in with a click of a button. So that means you have your existing infrastructure, and then you'll have your existing new designs that you can build towards. And it'll be a rule-based design, so we'll utilize automated rules to design around the existing infrastructure that we just imported in. Again, we can export plans and permits. This can help us with exporting plans and permits for construction crews. Also, another future state we're thinking about is how do we incorporate this into as-builts? Can we put this all into one platform? Can we, provide our construction crews with a tablet with an intelligent AutoCAD ABD model installed in it, where they can just draw intelligent lines? That way, when it's synced, all of it gets uploaded and put into our original as an as-built, and there's no human intervention, as in no one needs to go in and validate or check. It's all checked through rule-based checks, and your as-builts are already complete. Another thing we're looking towards is how do we export our SpiderCalc and software pole line analysis into our ABD, where we can just export and start continuing to draw as we do pole line inspections and pole line analysis or rebuilds or anything like that. So there's lots to look forward to, and as well as AI, maybe. There's a possibility in the future is maybe there can be an AI embedded ABD system where it'll tell you what suggestions there are to do future designs. If you already have an existing infrastructure, you feed into the system what you're looking for, what the neighborhood needs to feed, how many homes you need to feed. Then if an AI model can tell you exactly to choose which running line, because it already predicts how far you need to be from utilities, reading into the standards that are in the templates of how far the spacing needs to be, depending on the municipality or the state or the province. All of that can be done simultaneously, and that would be the future state we're looking at. Again, this is a partnership between SBS and Aecon, and we're hoping to innovate, collaborate even past our implementation testing phases, and hopefully we can develop this with our electrical and pipeline platforms as well. Thank you.